RADAR-CNS stands for Remote Assessment of Disease and Relapse, CNS, Central Nervous System. We're looking at three conditions: depression, multiple sclerosis and epilepsy. And it is about trying to make use of data from your mobile phone and from wrist-worn or other wearable devices. And we're particularly interested in what can be done with the kind of devices you can buy on the high street.
We are bringing together a really diverse set of people to solve this problem, where we have folks from the pharmaceutical industry, people from the software industry, leading academic centers, patient groups, because this is the kind of challenge which only a confluence of experts can solve. We are doing it in a public-private setting, so that everything that we do is going to be widely available for the public, and it will basically set the stage for future advances in this field.
I think the first challenge is to demonstrate that we have got meaningful signals from the data that we're collecting, so that it does actually relate to functioning, to mood or seizures or the clinical states that patients have. Second question then is designing the presentation of information and data so that it's actionable.
It may be easy enough to actually get signals that are correlated with a clinical rating, but that's not good enough. We have to get signals that tell us something we don't already know, something that you can't get from clinical ratings. It might be how somebody's performing in their own environment. It might be a way of predicting when someone's going to recover or when they're going to relapse. That really becomes a game changer if we can get to the point where we can have the sort of information that tells us what somebody's going to need 3, 5, 7 days from now.
We've been taking a range of the devices that we're interested in, and we've been comparing those against what is the gold standard video and EEG for seizure detection within an epilepsy monitoring unit within a hospital. We're looking at that data now, and we're starting to see interesting signals from EDA and activity, which seem to suggest that there is promise in these signals from these consumer type devices for seizure detection.
So we have enrolled approximately 100 patients so far, and we have captured quite a lot of seizures. It will be important to find an objective way to tell that a seizure is occurring. So we cannot only rely on subjective reporting on patient's memory.
Up till now, one of the biggest things with the stigma of epilepsy is that people don't know when their next seizure is going to take place. Lots of people don't get warnings at all. Some people find it extremely embarrassing as a condition. If the app could actually improve the chances of being able to predict when seizures take place, that would be an incredible advantage for people with epilepsy.
It's really important to involve patients in this sort of research, because we need to know right from the get-go what patients want, so we can change the research so that it fits with their expectations. We're halfway through the project already, and they're still making really dramatic changes to the way that we're following through with the studies.
People want to become more aware of their own patterns of behavior, because that is where they actually can change things. So you actually make patients the expert of their own experiences.
Multiple sclerosis is the most frequent neurological disorder cause of disability in young persons. We have some difficulties and problems in assessing what really happens to the patient. So if we have the possibility to have an objective evaluation of what is happening to the patient, it will give us a lot of possibilities to document and then to understand.
I see my consultant normally once a year if you're lucky, and I'm supposed to give feedback on what's happened throughout the year, and taking into account that people with MS, it's very common to have memory problems. You know, how are you supposed to remember to tell your consultant about certain things?
When you're a doctor in a clinic, or you're a researcher seeing a participant in a research study, you get these sort of snapshots of their clinical state. What could be game-changing if this actually works is that you are able to provide, the patient and the doctor together can sort of see the data.
I've been on and off with depression for a long time. I've been in the Bethlehem in the affective disorders unit twice for 6 months at a time. It had occurred to me that really there should be a way of perhaps using technology with mental health. What I understand is that they'll be able to observe your activity alongside your mood and how that changes over a period of time. The hope is that eventually they might be able to see ahead of time before the mood drops that you're going to go down, and then you might be able to do something about it. I think it's absolutely brilliant.
As individuals own their sort of digital readouts and they feel comfortable anonymously sharing them, then we can create a population level database of literally millions of people.
We're not designing a platform which is just for this project and then it kind of dies. You start allowing other projects to use the technology, you develop a community of researchers and software developers and so on who can actually input into it and improve it. We want to be able to take this from a kind of a nice research question impacting the real world.
We believe that in 5 years, when RADAR-CNS is said and done, we would have essentially created one giant exemplar of what these kind of technologies can do for patients and for physicians. The example that this project sets will be just as valuable as the actual deliverable that comes out of this project.